I have been asked to do number 21, which is to find the first four non-zero terms when the function is about 0 of exponential t cosine t. Now, just by looking at the function, by looking at these two functions, we know that this looks like that, and we also know that this looks like that. So we substitute t into the Taylor series for both of them. So exponential t would look like 1 plus t plus t squared over 2 factorial plus t cubed over 3 factorial plus t to the 4 over 4 factorial. And this goes on. And if we substitute t here, we know that this would just be minus negative t squared over 2 factorial plus t4 over 4 factorial minus t6 over 6 factorial. Now, we know that the function we've been asked to look at is just a multiplication of these two functions. So we would multiply the two series together. And that would just be 1 plus t squared over 2 factorial plus t cubed over 3 factorial plus t4 over 4 factorial. That goes on, multiplied by 1 minus t squared over 2 factorial plus t4, I don't know why I wrote that, over 4 factorial minus t6 over 6 factorial. Now, I'm just going to do these like we do regular algebraic multiplication. And so we would multiply the first term by this, then we'll multiply the first term by this, then the first term by this, then the first term by this. Then we'll multiply the first term again. We'll multiply the second term now by the first term here, and the second term by the second term here, then the second term by the third term, and we just go on with that. So to do that, our first couple of terms would be 1. So it would be, this is equal to 1, because 1 times 1 is 1. 1 times negative t squared over 2 factorial is negative t squared over 2 factorial. 1 times t to the 4 over 4 factorial is t4 over 4 factorial. And we get the idea. Then we do the same thing for the second term here. So we would multiply t by 1, that's t. Then t times the second term would be negative t. So this is, I should say plus t. Then we'd say negative t. T times negative t squared over 2 factorial is negative t cubed over 2 factorial. T times the third term would be t to the 5th over 4 factorial. And t times the last term would be negative t to the 7 over 6 factorial. Doing the same thing for t squared over 2 factorial, multiplying it by 1 would be t squared over 2 factorial. Multiplying it by the second term would be negative t to the 4 over 2 factorial times 2 factorial, because this and this are both the denominators. So, and then the next term would be plus t to the 6 over 4 factorial times 6 times factorial. And because we know our powers, we only need the first 4 non-zero terms. Our powers are not going to get as higher than 6. We can just stop here. And then the fourth term in the first one is t cubed over 3 factorial times 1, which is the same thing. Then times the second term would be negative t5 over 3 factorial 2 factorial, because we're multiplying the factorial in the denominator of both terms. And again, the next term would look something like t7. It would be t3 and t4. And because we know it's not going to get that high again, we're just going to stop here for this. And then we're going to do the same thing again for t4. Just going to use black again. For t4, which is the fifth term here, if we multiply it by 1, we know it's t to the 4 over 4 factorial. If we multiply it by the second term, we know it's negative t to the 6 over 4 factorial, 2 factorial. And our powers are not going to get as high as this again, so we're just going to stop there again. Now we want to collect like terms from each part, basically. So we're going to say we have 1 common. The first term that we see is 1. And there's 1t. That's t to the 1. We're writing this in the order of the powers, t. Now we're looking for t squared. And we have t squared here. And we have t squared also in right here. And so we have plus t squared over 2 factorial. Actually, we just want to write the coefficients for each. So I'm just going to write plus 1 over 2 factorial minus the coefficient for that is 1 over 2 factorial again, and t squared outside. So we know this goes to 0. We can just say right now that this goes to 0. And the next one, and the next power we're looking for would be t cubed. And we know that we have t cubed here. We know that we have t cubed here again, and that's it. So we're going to, again, write just the coefficients of t cubed, which is 1 over 3 factorial minus 1 over 2 factorial. And t cubed outside. And for t to the 4, because this goes to 0, this is 1, 2, 3. This would have been a third term. T squared right here would have been our third term. But because it goes to 0, it doesn't count. So 1 over 3 t cubed becomes our third term. And our fourth non-zero term, I should say non-zero term, our fourth non-zero term is what the coefficient of t to the 4 is. And for that, we know we have t to the 4 here. We know we have t to the 4 here. We know we have t to the 4 here also. So we're going to say 1 over 4 factorial plus 1 over 4 factorial again minus 1 over 2 factorial squared, because we have 2 factorial twice here. And the coefficient is t to the 4. So now what we have is just simplification of this. So this is 1, this is t, and this is simply 1 over 3 times 2, which is 6, and minus 1 over 2, so that's 1 over 3. So this is simply 1 over 3 t squared. And the fourth coefficient is simply 4 factorial is 24, because it's 4 times 3, which is 12, times 2, which is 24. And so that's simply 1 over 24 plus 1 over 24, which is 1 over 12. And 2 factorial is simply 2 times 1, which is 2. 2 squared is 4. So you have 1 over 12 minus 1 over 4. And if you do your math right, that should be negative 1 over 6. So we have negative 1 over 6 t to the 4. So we have successfully shown that exponential t cosine t is simply equal to 1 plus t plus 1 over 3 t squared negative minus 1 over 6 t to the 4. I just realized that I dropped a negative sign here. 1 over 6 minus 1 over 2 is negative 1 over 3. Negative 1 over 3. negative 1 over 3. So we have shown that the first four non-zero terms of exponential t cosine t is 1 plus t minus negative 1 over 3 t squared minus 1 over 6 t to the 4. And we know that this goes on, so plus dot dot dot. Thank you very much.